Hello, hi everyone, welcome back to the channel. So today in this video lecture we're going to be solving this problem, minimum cost to make at least one valid path in a grid. So this problem is one of the problems which are present in the series of Dijkstra algorithm. So let's read the problem statement. We're given a m into n grid where mn represents the dimensions of the grid, namely the number of rows and the number of columns respectively. Each cell of the grid has a sign pointing to the next cell you should visit if you are currently in this cell. That means there is a certain integer in each cell which represents a certain direction in which we can move. The sign of that cell can be, if it is 1, if there is 1 in that cell, that means we are supposed to go to the right, that is from grid ij to grid ij plus 1, right, moving one step towards right. If it is 2, that means we have to move one step towards left, that is from grid ij to grid ij minus 1, that is in the previous column. 3 means go to the lower cell, that is from grid ij to grid I plus 1j, that is move to the next row. Okay. If there is a 4 in the cell, which means go to the upper cell from grid ij to grid I minus 1j, that is move to the previous row. Fine. So these are the 4 integers that can be present in the cells of the given matrix. So notice that there could be some signs on the cells of the grid that point outside the grid. So there can be like certain cells which when followed accordingly points us outside of the boundary of the matrix. So what is the problem? The problem is we'll start at the upper left cell, that is 0 0. This is a starting cell. A valid path in the grid is a path that starts from the upper cell 0 0 and ends at the bottom cell m minus 1 n minus 1. Okay, that is the last cell of the grid. Following the signs on the grid, okay, the valid path does not have to be the shortest. So it doesn't have to be the shortest path, but it must follow the signs that are given in there. Fine, that's the problem statement. Now that is the definition of a valid path. So we don't have to find the shortest path, rather we have to find a path which starts from the top left cell and ends at the bottom right cell following the signs given in the grid. So we can modify the sign on a cell with cost is equals to 1. So suppose we are like moving along a path, now we want to modify the sign of some cell, just because like following the sign which is already there does not lead us to the destination. So we may change the sign accordingly, and changing a sign costs us 1 unit. Okay, and on a single cell we can exactly change the sign once. Fine. So for one cell I can change its sign exactly once. That's the requirement. What do we have to do is we have to return the minimum cost to make the grid have at least one valid path. So we just want to modify this grid somehow such that we have a path, a valid path which has the minimum cost. Okay, that means start from the top left cell, now move along some path while changing the direction of some of the cells such that you always end up at the bottom right cell. Now the changes that you make must be minimum, and that's counted as the minimum cost, and you want to find a valid path with the minimum cost. So let's better understand the problem statement using an example. So let's see this example. So here in this example the matrix that we are given is 1 1 1 1 2 2 2 2 1 1 1 1 2 2 2 2. So let's see the signs. We know that 1 represents that we are supposed to move towards the right. So in the very first row we are supposed to move towards the right. So here we are starting from this cell with the arrow marked yellow, and now we are just moving towards left. So we can keep moving toward we are just moving towards right. So we'll simply follow the signs as they are given in the grid. So follow these signs and reach this cell, that is the last cell of the first row. Here you can see that the direction here, the integer here points to the next cell, but there is no next cell towards right. So we have to modify this one because we want to reach this cell. Fine. So how do we modify this? I followed the signs because I want to minimize the cost. So I reached this cell, but here there is no way. I just have to modify the cell somehow. Now modify this towards the down direction. Okay, downward direction, because I want to reach the bottom cell. So that will count it as cost 1. Then when we move in the second row, after changing the integer in the last cell of the first row 2, it will be changed to 3, right? We'll reach this column, we'll reach this cell. Now we keep moving to in this cell we are directed to move towards left, and in this fashion we'll keep moving towards left until we reach this last cell. Okay, here again we have to change because we want to reach this bottom cell, but here this arrow, the integer here which is 2, is pointing us to move to the left, but there is no cell towards left of it, so we have to move downwards. So now we move downwards, that means we again change the integer here to 3, so we move downwards. So now the cost till this point becomes 2. So now we reach this cell, that is the first cell of the third row. Now this cell is pointing us to move towards the right, and all of the subsequent cells are same, that is they are pointing us to move, keep moving towards right. So we'll keep moving towards right until we reach the last cell of the third row, where we are again supposed to move towards right, but there is no cell towards right. Again we have to change the sign here. So we change the sign here from 1 to 3 again, and we reach the and we move to the cell just below it, and the cell below this cell, that is the last cell of the third row, will be the cell that is the last cell of the fourth row, which is my destination cell. Fine, and that's a valid path. How many, what is the cost? What will be the cost for this path? The cost will be, I change the direction here once, then I changed here second time, then here I changed the third time. So the cost will be 3, and that is the answer. This is the path with the minimum cost. Fine. Okay, now this is one of the paths with the minimum cost, although there can be multiple paths with the same cost, but I am sure, I want to make sure that this path has to be minimum. Let's better understand this example, why 3 is the minimum cost. So this is basically the example. Now we can see that in the very first row, all of the integers are directing us to move towards right. Okay, here. Now since I just want to reach this cell, that is the bottom right cell of the matrix, I have to somehow, out of these cells, these 4 cells, at some point I have to move downward once. That is the requirement, because I want to reach this cell. That means I at least need one change. Now observe this row. Here all of the cells are pointing us to move towards left direction here. But since I want to reach this bottom right cell, I will be required to at least move towards to the downward direction at least once. That means 1 will again be added. We have to change the sign of at least one cell. Now observe the third row. It is again pointing us to move towards the towards the right direction, but again I want to reach this cell, that is bottom right cell. So that means again I just have to move at least once. I just have to move at least one integer. I have to change one integer to 3. So that means 3 changes are necessary to reach the bottom cell. Hence 3 is my minimum answer, the minimum cost path. That is, move from this, move towards to the last cell, then move downward, move here, move downward, move left, move right, and move downward. Change here, and then finally change here. 3 is the answer. Okay. any other path will be of greater cost. Take this path. Move from this cell to this cell, change the sign here, 1 cost 1, then again change the sign, move downward. Okay, so 1 plus 1 2, now change sign again, that is 3, but here I again have to change the sign because this cell is directing us to move towards left, but I want to move towards right, so I have to change the sign again here. That is giving me a cost of 4. So the paths will give me a cost which is greater than 3. So 3 is the minimum cost that we can get. So how to solve these kind of problems? Okay, notice how can I solve these problems? Standing at any cell, standing at any typical cell, there are 4 directions to move: left, right, up, down. And our cell is directing us to one of these directions. Okay, and we don't know whether the direction to which this cell is directing is favorable or not. All other 3 directions which our cell is not pointing us to will require a cost of 1 unit. Okay, so what is the solution to, what can be the solution to this problem? Because maybe it is more optimal to change the direction here to reach the bottom cell in minimum cost. It may also be possible that we don't have to change the direction here to reach the destination cell. For instance, let's take this example. Here in this example, we start from this cell, and this is directing us to move towards right. So we move towards right. Again, this cell is directing us to move towards right. We move towards right. This cell is directing us to move towards downward. So we move downward here. Now this cell is directing us to right. So we move to right. Again directing us to right. So we move to right. This directing us to move down. We move down. This is again directing us to move towards right. We move. Finally, we reach finally we reach this cell, and we do not require any change of the sign if I just follow the signs which are there in the cells, and the cost will be 0 for this case. But if I follow the signs here, I will never end up in the target cell. So we just don't know, we have no idea in which direction to move so as to obtain the optimal path. That means we have to explore all of the possible directions. Fine. How? Let's see that. So what I will do is, I'm simply starting from node number 0. Okay, so I'll take a priority queue. So I'll be using Dijkstra algorithm to solve this problem. Let's see how Dijkstra can be used to solve this problem. So I will take a priority queue. I will push the starting cell, that is 0 0, and this priority queue will be sorted by the distance, and the distance for this cell is 0 because I am starting from this cell. So we'll have 0 0 0, this tuple. Now I will pop this cell, so this cell, from the priority queue and delete it from it. And then for this cell, what I have 2 options to move. Either I move towards right or I move towards downward direction. There are 2 directions to move, but here you can see that if I move towards left, if I move towards right, I do not require any change of the sign, because that's what our cell is directing. Our cell is saying move towards right. While if I move in the downward direction, I have to change the sign of our cell. So there are 2 possibilities from cell 0 0. Either I can move to cell 1 0 or to cell which 0 1. Fine. So there are 2 possibilities. Okay, so for this one, if I want to reach this cell, that is 1 0, the cost will be 1. The cost will be 1. While if I want to reach this cell, that is 0 1, the cost will be 0. Now again I have 2 cells in the priority queue. I will explore both of them. So I'll push them here. I will have cell 1 0 with a cost of 1, while I will have cell 0 1 with a cost of 0. Fine. Now again, this is deleted, this was deleted in the previous iteration. Now we have these two cells in the priority queue. Out of these two cells, I will pick this one, because these cells are sorted according to their distances from the source, while the source cell is this 0 0. So I will pick out this cell, that is 0 1. So from 0 1 here, I can move, that is this one, that this is a 0 1 cell. I can move towards left, I can move towards the downward direction, or I can move towards the right direction. I have three options to move. Fine. 0 1, I will have three directions to move. Either move to cell 0 2, that is this one, or to 1 1, or to 0 0 again. Now moving to 0 2, that is this one here, do not require any cost, because that's what our cell is directing us to. It requires 0 cost. While moving to cell 1 1 here, 1 1, this one, require us to change the sign here. Okay, so I have to change the integer here from 1 to 3 to move to cell 1 1. So that requires a cost of 1 unit. While to move from 0 1 to 0 0, the cost required is again 1. Okay, while so now I will push all of these three pairs again into the priority queue. So now this will be deleted, that is 0 1 will be deleted from the priority queue. So I'll push 0 0 with the cost of, what will be the cost for 0 0? What was the cost for 1 1? For 0 1, the cost for 0 1 was 1, right? So the cost for this would be, what will the cost to move to cell 0 0? It will be 1. But we already have a better cost to move for this cell 0 0, that is 0. We already have a cost of 0 for cell 0 0. That means I do not have to include this cell into the priority queue. So I just don't include it, but I include this cell, that is 1 1. So I also keep a distance matrix. So keep a distance matrix to figure out that the cells already have a better distance or not. My distance matrix for cell number 0, the answer is 0. That means we require 0 units of cost to arrive at the cell 0 0, because we are starting from that cell. For cell number 1 0, that is here, I require 1 unit. 1 0, this one, I require 1 unit. For cell 0 1, I require 0 units. For cell 0 2, this one, 0 2, this one, I require 0 units. For cell 1 1, I require 1 1 will be this one, I require 0 plus 1, that is 1 unit, because that's what I have calculated. 0 to reach 0 1, then 1 unit to reach cell 1 1, and I have to push all of these cells into the priority queue. So push 1 1 with its cost to be 1, push 0 2 with its cost to be 0. Fine. Now we have these two cells into our priority queue. Now we have three cells basically. We also have 1 0. Now out of these three cells, pick that cell which has the least cost or the least distance from the source cell. That is this cell 0 2. So pick out this cell. Pick out this cell 0 2, this one. Okay. Now from 0 2, I can move to 0 1. I can move to 0. I can move to 1 2 These are the two cells to which I can move to. It will never be optimal to move back to the cell 0 1, because we already have a better answer for 0 1, that is 0. So we will not have a better answer for this cell. So we simply move from 0 2 to 1 2. So we will simply move to 1 2, and the cost required would be, what will the cost required? So we have 3 here. That means we are simply being directed to move to that cell, that is from 0 2 will move to cell 1 2 without any cost. So it requires 0 units of cost. So for 1 2 1 2 store 0. Also push this into the priority queue. Push 1 2 with its cost to be 0. Fine. Now, so I hope you are following with me. Just stay with me. We are just about to finish it. Now we have 3 cells into the priority queue. We have cell 1 0 1 1 and 1 2. Out of these 3 cells, I will pick out this cell, that is 1 2. Why? Because it has the least cost, that is 0. So from 1 2, that is this cell, I have 2 directions to move. Either I move towards left with a cost of 0 units. Why? Because the cell itself is directing us to move towards left. So move to 1 1, or move to 2 2. To move to cell 2 2, I require cost of 1 unit, while to move to cell 1 1, I require 0 cost. Okay. So that means for 1 1 1 1, that is this is 1 1, I have a better answer, because in the distance array I have 1. So that means if I follow this path, then I will require 0 cost. So I'll update this answer to 0, and I push this tuple into the priority queue, that is 1 1 along with a better distance, that is 0. Fine. So to reach cell 1 1, just follow the signs which are there in the cells. Start from cell 0 0, move to right, then again move to right, move downwards, and then just move to the left once. Will reach the cell 1 1 with 0 cost. We don't have to flip any sign. Now from 1 1, also to move to cell 2 2, here this one, which is the target cell, I require 1 unit or 1 flip. So that means the cost would be the cost for 1 2, which is 0, plus this one, that is 2 2. So push this cell 2 2 here in the priority queue, and this is the cost to reach this cell that we have found. So we store 1 here, because this distance array is, again like we do in Dijkstra, is initialized with a very large number initially. So 1 is better than that very large number. So we reinitialize this cell 2 2, the distance for cell 2 2 to be 1. Okay. Now we have these cells into the priority queue. Now out of these cells, I will pull this tuple, that is 1 1 with distance to be 0, this one, and I will explore its adjacent nodes, adjacent cells. For 1 1, it is this one. The adjacent cells would be this cell, that is 1 0, and this cell, that is 1 2, this cell, that is 2 1. So there is no meaning to move to cell 1 2, because we already have a better answer for this cell than to move back to that cell. So we will just move to cell 1 0, that is this one, and to reach that I require no cost, because the cell itself is directing us to this cell. So move to cell 1 0 from this cell 1 1 1 0 with no cost. Then from 1 1, move to 2 1, that is this cell, with the cost of 1 unit, because I have to change this 2 to 3 to move downwards exactly by 1 unit. Fine. So hope you're getting what we are doing here. We are just performing the usual steps that we do in the Dijkstra algorithm. Now here we reach this cell, but we require 1 unit of cost. So what was the cost to reach cell 1 1? 1 1, it was 0. So 0, but we require a cost of 1 to move from cell 1 1 to cell 2 1. So for cell 2 1, I will push this tuple, these two tuples, 1 0 with 0, 1 0. I will also update the distance here in the matrix, because here you can see that for cell 1 0, this is 1 0 cell, the answer is 1, but we are getting a better answer here. So that means I'll have to update it. So I update its distance to be 0. And then I also push this cell to 1. This is out. So 2 1, and to move to 2 1 I require a cost of 1, because to reach 1 1 I require 0, plus to reach 2 1 I have to flip the sign of this cell, so it requires a cost of 1 unit. So that will be the tuple corresponding to this cell. Now we have these tuples. Now pull out this tuple, this one, because it has the minimum distance out of all the tuples from the source cell. So that means 1 0, this one, and here in the matrix 1 0 is this 1 0, this one, it contains 3. So now from this cell I can move back to the cell 1 1, I can move downwards, or I can move upwards. Now there is no meaning in moving to cell 0 0 and to cell 1 1, because we already have a better answer for them in our answer array, which is 0 for 0 0 and 0 for 1 1. So there can be no better answer than 0. So we simply move to cell 2 0. So from here I move to cell 2 0, and it requires no cost, because the cell itself contains 3, which is directing us towards downward direction. So I simply push this cell 2 0 along with its distance to be 0. So I require 0 cost to reach this cell 2 0. Fine, 0. So put 0 here. Now again this is out. Out of these tuples I again pull this tuple, because it has a shortest distance from the source cell. Now from 2 0, which is this one, I can move to right, or I can move towards up. There is no meaning in moving towards upward direction, because we already have a better answer for 1 0, that is 0. We can't go better, we can't have better than 0. So we simply move towards right. So from cell 2 0 move to cell 2 1, and the cost will be again 0. Why? Because the cell itself is pointing us to move to right, it contains 1. So we do not require any cost to move to cell 2 1. So that means move to cell 2 1, but we had cost 1 initially, so this will be discarded. So 2 1 with a cost of 0. I require no change in the direction of any cell to reach the cell 2 1. So for 2 1 we'll update the answer to be 0. Initially we had 1 for this cell. Now from 2 1 here I can move again. Out of these cells I pull out this cell now. So this was out, I pull this cell, because it is nearest to the source cell 0 0. So it has a distance of 0 from the source cell. Then from this cell 2 1 I can move to left, right, or up, but there is no meaning in moving to cell 1 1 or cell 2 0, because we already have the best answer for these cells. We can see that for cell 2 0 we have 0, for cell 1 1 we have 0. So we just move towards the cell 2 2. So from 2 1 I move to cell 2 2, and we require 0 cost, because the cell contains 1, which is just directing us to move to right by 1 unit. So that means it requires 0 cost. So for 2 2 we require 0 cost. So for 2 2 I update the answer from 1 to 0, which is the best answer we can get. Now in the very next iteration I'm again gonna pull this tuple from the priority queue here, which is 2 2 with 0, and here I have the best answer. And here, since I am pulling out this tuple, I simply end the Dijkstra algorithm right there, because this is the destination cell which I can have. Okay, so this is the destination cell. So since I reach the destination cell, I will simply return its distance or the minimum cost which is stored here in this array, which is 0. Okay, so that's all, and that will basically give me my answer. So the answer for this particular test case will be 0, and the path that we followed is just move from 0 0 to 0 1, then from 0 1 to 0 2, then from 0 2 to 1 2, then to 1 1, then to 1 0, 2 0, 2 1, and finally to 2 2. Fine. Just follow the signs in the given matrix and we'll simply find our answer to be 0. We don't have to flip any sign. So that's how this algorithm is working. Okay, so we are using Dijkstra algorithm because here we are using a priority queue. We can also solve this problem using breadth first search algorithm. That is an exercise for you people to solve it yourself to better understand the problem statement, that whenever such problem appears in next time, you people are able to solve this using this algorithm, this type of technique. Fine, so let's just see the pseudocode implementation. Okay, so this is the min cost function which we have, which takes in this grid. It calculates the number of rows in the grid, the number of columns in the grid, and initialize a cost array with dimensions n cross m. N represents the number of rows, m represents the number of columns, and initialize it with a very large number as we do in the Dijkstra algorithm. Okay, so we are running the Dijkstra algorithm over a grid, and for the source cell initialize the distance to be 0 because we are starting from that cell. Declare a priority queue and push the source cell along with its distance into the priority queue. Now the cells will be sorted according to this first integer, that is the distance from the source cell. We declare a direction vector or a direction array which will be used to navigate to the 4 directions that we have for any typical cell. Okay, that is the adjacent cells of any cell. Then I declare a hash map. Why? Just to map the directions with the integers given in the matrix. That is, if I want to move like towards right, which is this one, which will be moved if I add 0 to the x coordinate and -1 to the y coordinate, then that means I must have integer 1 in the grid. So in this fashion I will map all the directions with these integers present in the grid, so that given an integer in the grid, I can check to which direction the cell is pointing us to. Okay, then I simply run the usual Dijkstra algorithm, that is till this priority queue is not empty, pull out the top element from the priority queue and check if the cell that we have popped out is the destination cell. If it is the destination cell, then simply return the cost right from there because that's the minimum cost that we have obtained. Otherwise, here check if the cost that we already have for this cell is better than the cost which is associated with this tuple that we have popped out. If it is the case, then simply discard this pair because we have already found a better path to reach at this cell. So discard this pair. Otherwise, traverse all the 4 directions, and these xy coordinates represents the position of the new cell to which we are moving. So DRI will move us towards the x direction, while this will move us towards the y direction. Okay, and this is our current cell which we have popped out from the priority queue. So we are navigating to the adjacent cell. So standing at any cell, we are simply moving like right, down, left, and then upward. So that's how we are moving our coordinates. Now here check if the new cell is a valid cell, if it is within the boundary of the matrix. If it is the case, then that means calculate the change. So this basically calculate if we have to change the direction or not. So check here, check if the integer which is present in the cell from which we are coming, from which we are moving to the adjacent cell, if it is not equal to the direction towards which we have moved. For instance, we have moved towards right, and the integer which is there in the grid for the cell from which we are moving is 3. That means it is saying us to move towards downward direction. That means we have to change the direction here. We have to flip the integer. We have to flip it from 3 to 1. Okay. So that means we have to change the direction, and to change the direction I require a cost of 1 unit, and this will be stored here in this variable. Now find the new cost to move to the adjacent cell. Either the new cost is same as the cell from which we are coming. This is the case when the cell is just directing us towards the same cell in which we want to move. Otherwise we have to change the cost by 1. We have to increase the cost by 1. We have to flip the direction. So we have the new cost for moving to the adjacent cell. Now check if the new cost that we have obtained is better than the cost that we already have in the cost array. If it is the case, then simply update the cost array to this new cost and push the corresponding cell along with its new cost into the priority queue. The standard Dijkstra technique that we are using here. So in this fashion, we'll just calculate the shortest, the minimum flips or the minimum cost path to reach the bottom right cell of the matrix, and we'll return right from here. Cost n minus 1, m minus 1. So this is, so I'm returning this cost from here. This is called early stopping. Early stopping. That means whenever I pop an element from the priority queue, and if the element is the destination cell, if it is the destination cell, that means we are assuming that we already have the best answer stored in our cost array. So we return the cost right from there. Okay. So that's just all. Let's jump to the code implementation. Okay, so I'll be using C++ language to implement the solution. So this is the solution class in which you declare a min cost function which takes in the grid. So calculate the size of the grid, that is the number of rows in the grid. Calculate the number of columns in the grid. Okay, declare a cost array, vector cost array of n rows and m columns. Initialize it with int max. Initialize the very first cell with 0, and also declare a priority queue of vectors that will be so this will be a min heap. Basically create a PQ. So push the source cell into this priority queue, that is cell 0 0 with a cost of 0. Fine. Now also declare a hash map which will be used to point us to the directions. So before that I will declare another vector which will be used as to navigate to the adjacent cells. That will be 0 1 0 move. So the very first pair 0 1 will move us to right, then the next pair will move us to downward direction, then the next pair must move us to the previous column, and the next pair -1 0 will move us to upward cell. Fine. So in this fashion we'll have this direction array. Then we'll create a map of pair. Okay, so and let's call it PDIR, and for every shift just map the given integer which can be there in the grid. So we can see that if I move towards left, if I move towards right, then that means I will have 1 for this pair. If I move towards in the downward direction, that is 1 0, then for that I will have 3. To move to -1, that is to the to the left direction, I will have 2. Now finally to move to the upward direction, that will be -1 0, I will have 4. So in this fashion, so using this map I will be able to identify the given directions there in the grid MPD. Now let's run the standard Dijkstra till this priority queue is not empty. Okay, pop out the top vector from the given priority queue. Okay, from this vector check if the cost that we already have, if the cost that we already have is better, or before that check if the cell that we are getting, top 1, if the cell that we are getting is the source cell, top 2 m-1. If it is the source cell, then return the cost right from here, the early stopping condition. Fine. Otherwise, if it is not the case, then check if the distance that we have here, top 0, we already have a better distance for this corresponding cell in our cost array. And in that case, we simply discard it and we continue to the next pair. Now iterate over the neighboring cells. Okay, and here move to the adjacent cells. So the current cell is x coordinate is top 1 plus move to the dir I, move the y coordinate to dir I plus 1. Fine. Now check if it is there within the boundary of the given matrix. So x is greater than equals to 0 and y is greater than equals to 0. X has to be strictly less than n and y has to be strictly less than m. If it is the case, then that means it is a valid cell, and here I have to check if we require any cost to move to this cell. To do so, I will check if the integer that we had in the grid, the direction that the grid was pointing to for the parent cell, if it is not same as the direction for the current cell, that is MP, the direction that we have for the current cell, so MP, so we are moving like this, dir I, if it is not same, then so if the direction is not same, that means I require a cost. Let's put it 1 here. Finally, when I come like out of this condition, then here simply calculate the new cost. Let's call it new cost. New cost will be the initial cost that we have for the parent cell plus the direction cost that we have added. So if this new cost is better than the cost that we already have for the cell cost in the cost array, x, y, then we update the cost array for this cell, new cost, and we also push this tuple into the priority queue. So push x, y, and so on. So in this fashion we'll have our cost array calculated, which I am return right from here. Fine. So that's the implementation. That's all. That's the solution. Let's just see. Let's just submit it. Let's just try to submit the solution. Okay, there's this error here. Okay, I'm returning it from the while loop, but I have to return it from here. Okay, so positive answer. Let's see if it is accepted. Yeah, it's accepted. So that's all. So let's discuss the time and space complexity. We can see that the usual time complexity for the Dijkstra algorithm is E log V. E log V. This is the time complexity for the standard Dijkstra. E represents the number of edges, V represents the number of vertices, or we can also say E log N. Now, since we are performing Dijkstra algorithm over a matrix, the number of edges, like for any cell, from any cell, I can move to 4 directions here. Okay, I can move to 4 directions, right? So how many cells are there? There are n cross m cells. From each cell, I can have 4 edges. Fine. That means this represents the total number of edges that we have. This is the value of this E here. Log V. Log V. V represents the number of vertices, which is n into m. N into m. This will give me an overall complexity of n cross m log n cross m. Fine. Basically it's like V plus E log V, something like this. V plus E log V. Like in some cases we are given the time complexity to be like this, not this. But here if I calculate the equation for this one, it would be n into m plus this factor. Let's call it f. Now since this is the dominating factor, it will simply overall time complexity will give me n into m log n into m. That's the time complexity. While the space complexity, now we have to figure out the space complexity here. It is difficult to figure out the space complexity, but let's see that. We can see that we are using priority queue, and we are also using a distance or cost array. They may store all the cells. In the worst case, we have n cross m cells, and that is the space complexity, n cross m. Fine. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel and give your feedback in the comments below. And I hope to see you all in my next video. We'll be discussing yet another problem on Dijkstra algorithm.